All right, we are going to do 22.1 and 22.2 together because we're finding the volume of cylinders and cones. And we're going to see that they are almost identical, so that's why we're putting them together. So by the end of the lesson, we should be able to find the volume of a cylinder and a cone. So a cylinder is a three-dimensional figure with two parallel, congruent, remember congruent means equal, circular bases, so that's the top and the bottom, connected by a curved surface. An example is a can. Okay? So, right, there's one base, it's not a very good circle, but that's okay. And then here's the other base, and then they're connected, and this is a curved surface, right here. All right, so a cone is a 3D figure with one vertex and one circular base. So obviously that's a cone. So we have our circular base, and the vertex is that spot right there. So a cone is basically a pyramid with a circular base. Okay, and a cylinder is a prism just with circular bases. Okay, so we're going to do cylinders first. So the volume of a cylinder with the radius is the area of the base, big B, times the height. So it's the same, actually the same formula as volume for prisms, right? Big B, area of the base, the foundation, times the height of the prism, what connects the base with the base. Okay, and you can see it in the picture. The only difference is that they will break it down for you a little bit more and put pi r squared. Okay, so that right there is our big B times the height. So it's just like prisms. All right, so we've got this, we actually have two examples here. This was not cut very well, so there's two examples, okay? So this is just a can. It's got a radius of 3 and a height of 10. So I'm actually going to always use this one for volume of cylinders just because it's already broken down for me, right? So I'm going to go volume equals pi times radius squared times height. So area of the circle, so pi times 3 squared times the height of the prism, 10. So we can do some of this in our heads, right? So pi times 9 times 10, and then we can do 9 times 10, so we get 90 times pi. If we wanted to stop there, we would just say inches cubed. That'd be a more exact answer. It's inches cubed because it's volume. We talked about that in the last lesson, but also because right here is inches squared, and this is inches. So inches squared times inches cubed. But we want a more, maybe even a more precise answer, so we at least have an idea of where it's at. So we're going to go about 90 times 3.14. Remember, the about is because 3.14 is an estimate of pi. So this is approximately 282.6 inches cubed. So that's kind of more our final answer, but this also, if it says so, works as well. Okay, so one of the bass drums used in a marching band has a diameter of 18 inches and a depth, that's the height, of 14 inches. Find the volume of the drum to the nearest tenth. So we're going to use the same formula. Volume equals pi times radius squared times h. But this gave us the diameter. And I can't use the diameter, so I'm going to have to go diameter divided by 2 to get my radius. So we're going to do 18 divided by 2, which is 9, to get our radius. So we cannot use the diameter. Okay, so I'm going to set this up. So pi times radius, oh, didn't mean to put radius, sorry. 9 squared times 14. Depth and height are kind of the same idea. Depth just is down version, and height is when we're kind of looking at it towards up. All right, so here's what I'd like. Maybe pause here, do the calculations yourself. Once you think you have the volume, push play, and then it does say round to the nearest tenth, so make sure you pay attention to that. Okay, so hopefully you've done it now. So we're going to go pi times 81 times 14. I'm going to take 81 and times by 14. So pi times 1,134. It does say round to the nearest tenth, and it does say use pi, so I can't stop here. So I'm going to now go about 3.14 times my 1,134. And initially I get 3,560 and 76 hundredths, but it says nearest tenth. So I need to say 3,560 and 8 tenths inches cubed. This is our final answer because of rounding. And it's definitely an about now because we also rounded our final answer. So that's another reason this one's about. All right, hopefully you got the same answer. Okay, so here's cones. And if you notice with a cone, the only difference with a volume of a cone is that it's 1/3. Look at everything else is the same. Pi r squared h. So what they're basically saying is a cone and a can that have the same radius and height, a cone is 1/3 of it. Basically, if you stuck 3 cones with the same radius and height together, you would get a cylinder. So I'm going to kind of show you. I can't do it. You don't have to draw this if you don't want to, but here's one cone. And then if I draw what's called a right-angled cone, oops, didn't mean to delete that, here, and then connect it here, and then do a third one. Oops, I meant to change the color. And these ones actually would overlap. It makes a cylinder. And they're kind of in there, but so that's why. 3 cones with the same height and radius will have the exact same volume of 1 can cylinder, same height and radius. So that's why we just find the area or volume of a can or a cylinder and then just divide it by 3. It's kind of like a triangle is half a rectangle. The only difference is a cone is 1/3 of a cylinder. Okay, so we again have 2 examples here. So if you want, you can split it, but these are actually 2 examples. So we have this cone, okay? So I'm going to go volume equals, I don't know why I put 2 equals, 1/3 pi radius squared times h. Here's my radius, here's my h. So 1/3 pi 2 squared, and then times 8. So 1/3 pi times 4 times 8 equals 1/3 times pi times 32. We're going to want to do the 1/3 last, just because we have to estimate once we use pi, and so we tend to always use the 1/3 last so that we can round it to a better decimal. Okay, because if we try to divide by 3 first, and we have things that don't divide by 3, we're going to get a repeating decimal, and how do I times that by pi? So I'm going to actually do 32 times 3.14, 100.48, and then I'm going to times this by 1/3. So remember, timesing by 1/3 is the same as dividing by 3. So if you're going to do in your calculator, take 100.48 and divide it by 3. Okay, and then we can round. This doesn't say it, but let's round to the nearest hundredth. So it's about 33.49 inches cubed. Hopefully you're kind of checking my math with your calculator as well, so you understand this. But we're going to round these because of that dividing by 3. Alrighty, so here is a geography project where Karen built a clay model of a volcano. Volcanoes are cones in the shape of a cone. Her model has a diameter of 12 inches and a height of 8 inches. Find the volume of clay in her model to the nearest tenth. And they do ask that you use 3.14. So for this one, I want you to pause. I'm not going to start it at all, set it up for you. I want you to set it up, start it, do it, and then maybe even push play a little bit as you go so you can check as you go. All right, I don't want you to get to the end and it's completely wrong. So do a little bit, push play, see what I did, do a little bit, push play, so on, okay? All right, so this is diameter. I have to take diameter divided by 2 to get my radius. So that's 12 divided by 2, which gets us 6. I have to do that first before we can start. So I'm going to go volume equals 1/3 times pi times 6 squared times 8. So 1/3 times pi times 36 times 8. 1/3 times pi, and I'm going to take 36 and times it by 8 and get 288. This is where I'm going to have my about symbol because I'm going to change it and do 1/3 times 3.14 times 288. I'm going to take 288 times it by 3.14. We get about 1/3 times 904 and 3200ths. And then this is where I'm going to divide by 3. And so I get my volume to be approximately, it does say to the nearest tenth, so 301 and 4/10. And we are at inches cubed. That's your final answer. So hopefully you got the same thing. Check me and let me know. Put your questions. All right, so things to remember. The cone equals 1/3 of a cylinder. Okay, remember the diameter is half of the diameter is the radius, have to have the radius. I think those are the main things. So here's 2 examples. Okay, again, if you want to split it right there, make sure you do both. Pay attention. This is our diameter. This is a diameter. So you're going to have to do a little extra step. And then remember height and height. Okay, until next time.